Modernizing .NET Apps for Azure with Scott Nichols.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. Make sure to go to www.azuredevops.show for past episodes and show notes. And the goal of this podcast is to empower you and your team with the information that you need to move fast, deliver consistent quality using the .NET ecosystem, and to run your software systems with confidence in Azure. And for those of you running .NET or Azure user groups, I've been doing a lot of online video presentations lately. And so if you're running one of those groups, I'd love to give a presentation for you. Now, our sponsor for the podcast is ClearMeasure, which is my company, and it's a software architecture company. If your team needs some help doing more internally, please get in touch. And if you are a .NET developer and would like a path to become an architect, we are hiring. Just apply on the website, clearmeasure.com. 4 positions are open at the time of this recording. And today we have part 2 of our interview with Scott Nichols, a senior cloud solutions architect at Microsoft. Part 1 was released in the preceding episode. Now, Scott works for the commercial enterprise division serving the West region. He's also the .NET and Azure user group leaders in Boise, Idaho. And we joined this interview as we transition from talking about the state of Azure and the cloud industry and move more into talking about how customers are modernizing their existing applications and infrastructure for Azure. What infrastructure as code tools do you see having the most traction between ARM templates, Terraform, other products, plain PowerShell?
Yeah. So I really do like Terraform. I think Terraform is a great product. It works on all 3 clouds and on-prem. So I would never discourage anyone from using Terraform. They're a great Azure partner. However, if you're going to be a cloud professional, you're going to learn the native infrastructure tool for that platform. In Azure, it's called ARM. We do have a new DSL called Bicep coming out. It's an abstraction over ARM, where like I said, ARM is nothing more than a JSON configuration file that when you deploy it, it's going to read that configuration and it's going to deploy your infrastructure based on that config. Bicep now is a DSL over the top of ARM. So it's more, so people who have development backgrounds say, oh, this looks a lot more, and it looks a lot like Terraform actually. Why did Microsoft not just embrace Terraform? They actually did. So if you look at Azure today and you look at some of our deployment tabs, you're going to see there'll be a little tab there that says, hey, I want to see it in Terraform. And a lot of our services now, you can see it'll generate ARM code, PowerShell code, or it'll generate a Terraform script for you. And also a lot of them are having Ansible scripts as well. You can see Microsoft will pre-gen an Ansible script. But under the covers, everything is ARM. So as a professional who's a professional in Azure, you definitely want to spend some time and understand our native ARM capabilities, because there's never 100%, right? I will say Terraform is mapped over about 95%, but so there might be a situation where the Terraform module doesn't have some ARM capability, so you have to just tell Terraform, hey, Terraform, call this ARM module or ARM template because it's not built in, and you have to wait for the teams to catch up. But Terraform's a great partner. I will say HashiCorp, right? So HashiCorp runs Terraform. Yeah, they're great. Definitely. And I would say from a professional perspective, definitely learn Terraform. It is the number 1 infrastructure code platform out there, the fastest growing. It's got great integration in Azure, and it will, from a skill set perspective, even if Microsoft comes out their own thing, they all look very similar, right? So like I said, our new Bicep DSL language, it's very Terraformish, so it's kind of like, when you're a .NET developer learning Java, they're kissing cousins, right? So once you learn one infrastructure code platform, they all are very similar.
So do you have any customers that have used Bicep yet?
No, because it's not. It was just released.
Okay.
So it's still in private preview, and we're working on it. They might talk about it at the .NET conference this week some more. So they are encouraging developers to play with it now. It's in public preview. So yeah, it's out there. And
all right. Well, Now here you've been to so many customer implementations. adopting the cloud. There's a question. I don't think the industry has a good answer yet, but I want to get your take. Where you have a .NET application, and you have maybe ARM templates that can create the infrastructure and then deploy the application to it, even if it's just simple as a SQL database and app service. Mm-hmm. But then you have some other things like maybe a firewall network security group or a storage account. How do you see the DevOps pipeline set up? Is it an infrastructure pipeline and then an application pipeline? When you think, well, I need to change something about my infrastructure, but I don't need to rev my application, or I need to rev my application and it requires one more port to be open for this feature to work. How do you think about that, and what do you see being successful in your customers?
Yeah, we recommend, as in Microsoft's cloud architecture guidance team, we recommend segregated templates, right? So you're going to have your infrastructure team create templates that are just laying down the infrastructure. And let's just give it an environment, Dev 2, right? So we're going to create a complete environment which really doesn't care about the app, right? It's just, this is creating the infrastructure that app or suite of apps need to run on. Then after that infrastructure template is laid down and verified, you have your second set of templates coming through, which are going to have a lot other things. So an infrastructure template like Terraform, it's just looking at infrastructure, right? So it's that hardware layer that it's creating. But what it doesn't do is it's not going to configure the app service, or it's not going to configure the database, right? That's an app that you might actually want to use something like Ansible or .NET or PowerShell. After the infrastructure spins up its code, you have another pipeline coming behind it that's revving the applications or doing something to the server of Linux or the Windows server underneath, right? So yeah, we definitely recommend using inherited or layered templates, dependencies. So your pipelines. So if you're starting from scratch, like a brand new environment, you're going to run your infrastructure template first. It's going to lay everything down, rev up the environment. Then your app template, before it even runs, it's going to do a check and say, hey, is my infrastructure at a point where I can even go? It'll do a quick check, and if it's yes, then the app pipeline is going to go and deploy itself. Yeah, you definitely want to keep them segregated, because you are correct. You are completely right. You can definitely rev your environment, your hardware, and you don't have to rev your app, or you need to rev your app and don't rev your hardware. So you definitely want to keep them separate.
Okay, that's good guidance. Now, what about for the small tweaks, like let's just a storage account with a container where, you know what, we need to split this container, where some of the blobs in a container, where maybe the application doesn't care because it just needed which container to go to get the certain one. So a little key change is fine for that. But on the infrastructure side, you're creating 2 new containers, but then you're getting rid of the original container. So there's some destructive changes. Does the ARM template really know what to do there, or?
So the ARM template won't know. So the ARM template, you'll have to, you'll probably use something like PowerShell or something where you're going to say, hey, we're actually going to, in flight, we're going to create some additional nodes. We might do some sharding, like you're talking about, right? Like, hey, our architecture's gotten to a point where we can't, actually, here's a common one that people will run into. A storage account is limited to 500 IOPS, right, per second. So now, but it has, you can put petabytes on there, right? But what people can run into if you have a really, really, really busy website is you're not going to be able to keep up with the reads and writes. So you might have to shard your storage accounts just to get IOPS performances. So now you have to put this abstraction layer and create this sharding type thing. Now, granted, you have an endpoint that the developers is not going to change. So the software is probably not going to change at all, but you're going to have to completely change out your underlying architecture to a sharded type storage account versus a single account. So that is going to be some type of script you're going to write. It could be you can use an SDK on .NET. You can write it in .NET. You can write it in PowerShell. But you're going to, in this process, you're going to say, hey, we're going to create these new nodes. We're going to migrate data, make a copy. We're going to shard the data. And then once all that's done, then we're going to switch the endpoint. So, the new endpoint now is, so you will have some gap, as the endpoints are being switched, you could lose a few seconds.
Okay,
right?
so just stick with PowerShell then and use Azure
PowerShell
SDK.
is not going away. PowerShell or one of the SDKs, right? .NET or PowerShell, you're still going to use them.
So if app version 1.5 requires this new change in the infrastructure version, 1.2 or whatever version is, what's the mechanism in Azure that would know that that PowerShell script has not been run yet or has already been run yet, so that it doesn't run it again?
Okay, so ARM is stateful. So when you create an ARM template and you run the ARM template, and let's say inside your ARM template, you've got configuration for servers and various services, it actually is pretty smart. It understands. So if you try to run an ARM template over itself again, it's actually going to detect that it's actually already it's running. So it's not going to clobber it. Terraform with its state capabilities does the same thing, right? So that's one of the reasons I don't actually tell people, hey, in the early days, we used to just use PowerShell, right? I actually discourage people from using PowerShell as their primary infrastructure code because of that lack of state. ARM and Terraform can manage that state, so they understand the current and where it needs to go. So it builds that Delta file underneath, and it doesn't clobber. Where if you just brute force it in PowerShell, oh yeah, you're going to spin up a bunch more servers, or you could clobber a server, right, and just take it down. So yeah, use those infrastructure code technologies because they have that built-in state and Delta where they can check and won't clobber your existing environment.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
All right. Well, there's so much more that we could get into if we had the time. But as we go, there's a lot we talked about for people that are looking to figure out how to get their application into Azure and figure out, do I need to change nothing and just shift it, or do I need to change everything? What would you recommend their next step be?
Yeah, we actually, so part of our migration strategy, we work with customers, we call it our 5 R's, rehost, refactor, kind of go down. So basically what we recommend people to do first is, if you're dabbling with the cloud, is don't change anything right now. Just spin up your Azure account, and whatever you have on-prem, just rebuild it. If it's IaaS today, rebuild it in Azure. Just start getting comfortable and rehost your app, right? It's like, hey, what do we have on-prem? Let's do as few changes as possible, and let's see if we can get it working in Azure, right? That's probably 95% of the time, that's what we do with companies, unless they're in a greenfield. They have a whole new app that they want to design. We're like, okay, yeah, don't waste your time on designing your old tech. Let's do that one cloud native right off the bat because it's a greenfield app. But your brownfields, let's just as few changes as possible, because we don't want to, whatever errors happen, we don't want to have to fight the infrastructure errors with the migration errors, right? So that's our recommendation, is just move it over for brownfield, move it over as close to the existing architecture services as you can. Then you start peeling it apart. You say, okay, now that we're in the cloud, we can scale servers, right? We can bump up and down. Well, right now we're on a single server that's not behind a firewall. So let's add an Azure firewall and put a couple servers and just gradually kind of take advantage of these cloud capabilities. And then there's a thing called scale sets in the cloud, which all 3 clouds have. And that's a concept where you have a server instance, where that cattle thing, right? Where you have a golden image server, but you can create a configuration file based on metrics, 80% CPU, RAM, throughput, whatever, and it will automatically scale from one server to thousands of servers based on your need. That's a scale set. That is not something you can do on-prem today. So we say, hey, start re-architecting to take advantage of these scale set compute nodes. And same with paths, right? And then start, hey, let's take a look. If you're an Azure shop, a SQL Server shop, let's see if you can migrate one of your databases to Azure SQL. It's not 100% compatible, so you have to run your database compatibility check. Or if you have a greenfield database, let's put that there and start doing your testing. So what I'll tell people, it is CIOs hate it when I say this, but it is a 2 to 5 year journey, right? From 100% on-prem to getting, if you were to say you were a startup company born in the cloud, to look like that for a decent sized company, it takes a few years. Obviously, the bigger company you are, your cloud can be more on the 5 year side. If you're a small company, you could definitely probably within 2 years or a year, you could easily be 100% migrated. And I won't say modernized, because even then, you think about your code base and your testing, you got to redo your pipelines, and your teams have to learn a lot. And that's what I'll say is, to leaders out there listening to this, is it's a big jump for your IT, your staff, right? It's probably easier for the software engineers out there because they're used to rapid change and they're used to pipelines and checking code in and checking code out. So the cloud's not, from what I find is getting the software developers to understand microservice architectures, within 3 months, I can pretty much work with any team and they're ready to go cloud native tomorrow, right? It's the infrastructure guys, the brothers over there. And it's a struggle for them. And that's because so much has changed, right? They're not software engineers by trade. They're not used to writing scripts. They don't know how to use source code, but they have to modernize, right? And it's huge, and it takes that team years, as well as security. Security is another obstacle. If your company has a security team, they've got to learn a whole new world for them because cloud security is a lot different than the segregated on-prem security. The other thing we'll say is on the IT pro side is if you look at a data center team, you're going to have a network engineer, a storage engineer, a WAN engineer, a LAN engineer. You have all these very specialized silos. In the cloud, you have an infrastructure engineer, a cloud developer, and maybe a solution architect. That infrastructure engineer has all the skills that all this combined is. They have to know about storage and compute and everything else. Why? Because now it's all a script. You're not managing all this heavy infrastructure in what Microsoft or AWS or your cloud vendor is. So you have to understand the concepts and know how to take those Lego blocks and stitch them together and understand the limits. And then a solution architect, again, they're the owner of the Lego blocks. They understand how they're all plugging together. And then the cloud developer, they're like, okay, how do I tweak my .NET app to use an Azure function, right? Lambda, right? Or something like that. Like that's a new kind of concept. So we do have to tweak our code to take advantage of that kind of architecture. But like I said, not a big stretch for developers. They're just like, oh, it's just another abstraction. They get that. They've been doing that for years. Mm-hmm. So typically we put most of our emphasis is on working with the IT pro community on really getting them into the cloud. Software engineering, most of our work is going into pipelines, right? Trying to really get them saying, hey, Agile and DevOps is not new for the software community, but what you're going to do in the cloud is, right? The cloud, it's mandatory, right? And if you want a secure cloud, you have to be using DevOps, CI/CD pipelines to secure your cloud code. Otherwise, it may not be secure.
Yeah.
So we've kind of beat that in with the development community. It's like, hey, let's really harden those pipelines and really get you thinking infrastructure code. And probably different teams hate it, but do you create a DevOps team or an SRE team? There's definitely arguments on both sides, but what I see is most organizations will create an SRE team or a DevOps team on the developer side of the house because it's definitely a lot of developers. They'll typically
define SRE.
Site reliability engineer. Good. So Google, IBM, even Microsoft uses that term, but basically you can interchange SRE and DevOps engineer, same mm-hmm. role. Basically, you have an engineer who is responsible for the infrastructure. And probably the biggest shift is you think like a developer is beholden to features, right? So the development team is still focusing on features for the app. The DevOps engineer is focusing on capabilities of the infrastructure, right? They're not too focused on, hey, we need a new drop-down box or here. They're like, and the difference between the DevOps engineer on the team is, let's start saying the app is having performance issues. Well, it could be the software, but it also could be the infrastructure, right? We need to switch something out. The DevOps team has the capability because they own the production. They could completely switch out the database. They could completely switch out the caching tier. They can completely switch out the infrastructure. And the development team, the feature team doesn't care. They're just worried about their app. So now you've got this new class of engineers that they're working really close with the application developers, but they have autonomy to completely tweak that infrastructure. And one we see a lot is like the database side, right? So in the old world, everyone would throw everything in their monkey's uncle in a SQL database, right? Mm-hmm. Today in the cloud, to take some ThoughtWorks, right? We call poly persistence. Most modern cloud apps might have 5 different data stores, right? You're going to use a SQL for your reporting. You're going to use a NoSQL database. You're going to use another store to store your logs. That's not SQL Server, right? Because it's too expensive. You're going to take more advantage of your blob storage. So you might have 5 different data stores that are shaped for your data, and thus the formation of we're seeing a decline in the need for DBAs. So now what we tell people is like, you don't really need a DBA. What you need is a cloud data architect or DSA, data solution architect. And this data specialist is going to know how to deal with Cosmos DB, MongoDB, SQL Server, blob storage, all the places you persist your data. This data person is going to become a specialist in data persistence. Because you don't, if you think about it, when you have SQL Server or Mongo or Postgres, all your databases now are managed code. Do you really need a DBA that knows how to tweak every piece of that? No, you don't, because Microsoft or Amazon or whoever is managing most of the hard stuff for you. You just have to say, how many compute cores do you want, right?
Right.
And then how much, and so now your data people have to kind of get spread out a little bit and say, hey, we're moving beyond relational databases here. We're going to take advantage of native blob storage. We're going to use persistent queues. We're also going to use things like NoSQL. So we're going to use Mongo APIs, Cassandra, the various NoSQL APIs for our app.
Mm-hmm. Awesome. Man, that's a lot to get into, but Scott, I really appreciate you coming on the show. This is a lot of good information. Thanks so much.
Yeah, no, this is it's what I'll tell people out there, even people getting into, like people coming out of college, and I talk at a college, is this is a great time. Again, in IT, there's always, that's one thing I love about this industry, is there's always change is the constant, right? So, and the cloud is just ushering in yet a new age of change, rapid change. And I really do think if you're a developer today, the cloud is gold, because now, Jeffrey, you've been around a long time too. It used to take us 6 months to wait for infrastructure. Now, as a developer, you can dream up a solution and you can be up and running in a world-class capability where you could be running out of your garage. For startups, this is awesome, right? Because now you can literally spin something up that can support 10 million people, no problem. Now, I'll close on is, when you guys push your app to the cloud, these cloud vendors make money on throughput. So if you're really successful in your business, really think about your monetary value, because if you have to spin up 10,000 servers to support your load, you better have a way to pay for it. So that's a business side thing. Literally, even as a technical architect, we actually work with companies, say, hey, how are you monetizing this, right? So if you're, like I said, you have this cool AI idea where you want artificial intelligence, but you're going to spin up a lot of nodes to do this. How are you going to recoup the cost to pay Amazon or Microsoft or Google for that compute? Think about that in your product stack as well. Now you have to put that business logic or that business monetary. How do you make money? Because, like I said, now you can spin up the world, but you're going to have to pay for it at the end of the month. So.
Yeah, good point. Awesome.
Well, this has been great.
Yeah, it has been. It has been really. Hey, I've learned a lot. Really interesting. I appreciate it.
Okay.
All right. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.